Welcome to the Fall 2012 presentation of Oregon's Integrated Water Resources Strategy. The project team that developed this strategy was led by the Oregon Water Resources Department and also included the Oregon Department of Environmental Quality, the Department of Fish and Wildlife, and the Department of Agriculture. Special thanks to the Association of Oregon Counties for assistance with this production. The materials discussed here today are available through the Water Resources Department's homepage. Simply click on the Integrated Water Resources Strategy. It is estimated that approximately 2.5% of the world's supply of water is fresh water. Of that, only 30% is groundwater, and only 1.3% is surface water, as noted in this figure. Water is one of Oregon's most precious natural resources. With more than 100,000 miles of rivers and streams, 360 miles of coastline, and some of the cleanest lakes in the world, Oregon is renowned for its water. Our rivers and streams not only provide natural beauty, but they supply the water necessary for drinking, industry, agriculture, and fish and wildlife. In an average year, Oregon can expect to see an estimated 100 million acre-feet of water fill our lakes and streams and recharge our groundwater aquifers. This includes Oregon's surface water and groundwater combined, not counting the water that evaporates from plants or from the land's surface, or water that originates outside the boundary of our state. This totals about 100 million acre-feet. Water users in Oregon divert about 9 million acre-feet of water each year for out-of-stream uses. This represents approximately 8% of the 100 million acre-feet of water described earlier. Water resources serve four primary types of user groups: agriculture, municipalities, self-supplied industry, and domestic users. Within the remaining 92% are flows specifically protected by in-stream water rights, held in trust by the state. In-stream flows are protected by federal biological opinions and other flow requirements. These protections are difficult to quantify in a pie chart, as they are expressed in terms of stream flow or flow rate rather than a volume of water. The water that stays in-stream and in the ground sustains aquatic species and ecosystems. In-stream flows also support Oregon industries, such as fishing, recreation, hydropower, and navigation. The remainder of the 92% presents a question for the 21st century in Oregon. If Oregon is viewed as a wet state, why are we facing water challenges? For examples of water challenges in Oregon, consider location, timing, form, water quality, and physical barriers, as just a few examples. First, location. Although the average annual precipitation for the entire state of Oregon is about 30 inches, water is not distributed evenly throughout the state. Precipitation varies widely across Oregon, from as much as 200 inches at points along the coastal mountains to less than 8 inches in areas of drier eastern Oregon. This disparity in the location of water means that some Oregon communities often experience flooding conditions while others are experiencing drought. Similarly, the distribution of groundwater varies throughout the state, as we'll note in a later slide. Second, timing. The arrival of precipitation in Oregon, whether by rain or by snow, typically occurs between the months of October and April. This stands in stark contrast to the months in which water demands are at their peak for most uses. The graph demonstrates this mismatch in timing, with the green line representing pasture crops peaking in demand for water during the months of June, July, and August. The blue line, representing typical stream flow distribution in western Oregon, hits a trough during these same summer months. Historically, water users in the agricultural and municipal sectors have met their summertime needs through storage, using a combination of above or below ground storage and natural storage, that is, snowpack. In-stream needs are difficult to place on a graph like this, as different species require stream flow at different times of the year for different biological purposes. Generally, in terms of timing, low stream flows during the summer months represent the greatest concern for meeting in-stream needs. Third, form of water. Oregon, like much of the Northwest, is highly dependent on temperature-sensitive springtime snowpack to meet growing and often competing water demands. A study completed by the Climate Impacts Group at the University of Washington indicates that approximately 50% of Oregon water users are located in areas of the state that are dependent on snowpack to meet their water needs. This means that water availability significantly depends on the presence of natural storage, with water becoming available during heavy use periods as a result of snowmelt. These maps show the effect warmer temperatures could have on mid-level snowpack in Oregon. With an increase of just 3 degrees Celsius, precipitation that typically arrives in the form of snow, depicted in the white and yellow areas in the upper map, could instead arrive in the form of rain, depicted as bluer areas in the lower map. Precipitation as rain instead of snow poses several challenges to water systems, such as flashier, flood-prone systems, decreased summertime runoff to surface water, and reduced recharge to groundwater aquifers. Those users in-stream and out-of-stream that are dependent on snowpack for summertime water could see significant decreases in water when they need it most. Fourth, water quality. Water quality is compromised in many areas, driving up the cost of treatment for municipal and industrial water users and limiting the accessibility to clean water for fish, wildlife, domestic users, agricultural, and recreational users as well. More than 1,860 water bodies are impaired and not meeting water quality standards, including more than 30 lakes and reservoirs and about 22,000 stream miles. Temperature, sedimentation, and nutrients are the leading pollutants that impair Oregon's rivers and streams. For lakes, ponds, and reservoirs, dissolved oxygen and habitat alteration are the two most common water quality issues. Impaired water quality does not affect surface water quality alone. Groundwater contamination is a serious issue in some areas of Oregon. Ambient groundwater quality studies over the past 20 years and routine monitoring of public water supplies have found that 35 out of 45 study areas show some impairment or reason of concern. Nitrate is the most commonly detected contaminant, followed by pesticides, volatile organic compounds, and bacteria. What's the effect? As mentioned earlier, contamination of drinking water supplies poses human health risks, as well as higher costs to monitor and treat. Poor water quality can pose concerns for agriculture users too, particularly for stock and for food crops. In addition, some toxics can be lethal to fish and wildlife, whereas others can result in reduced fish egg production, nest and brood abandonment, lower disease resistance, and reduced adult survival and lower population abundance. The most visible indicator species are native salmonids, salmon, steelhead, and trout. Since 1991, NOAA has listed 27 Pacific salmonid species under the Endangered Species Act and has delisted 0 species due in part to water quality problems. Fifth, physical barrier. Diversions that lack proper fish screening or bypass devices can increase fish mortality and injury as fish enter diversion ditches, machinery, or irrigated field. In December 2011, the Oregon Department of Fish and Wildlife published an initial statewide look at fish passage barriers, showing locations where barriers may be posing problems to native migratory fish. Some of the barriers identified are passable barriers. Others are partially or completely blocking passage. For a significant percentage, 43%, it is unknown whether these barriers are passable or not. One significant challenge is groundwater. This map is a combination of information from state agencies. The Water Resources Department has designated groundwater administrative areas where water levels are declining faster than they can recover. These designations, called classified, limited, critical, or withdrawn, mean that certain protections apply in these areas. Because of the interaction between groundwater and surface water, the Deschutes study area, marked here, has special rules in place to protect scenic waterway flows. The Department of Environmental Quality's groundwater management areas are also shown here. These are designated when groundwater in an area has elevated pollution concentrations. All three groundwater management areas in Oregon have elevated nitrate concentrations in the groundwater. The data and information depicted in this map is of particular importance in the Integrated Water Resources Strategy because it reminds us that while groundwater is one of our most valuable assets, we actually have very little groundwater information available to us on a basin-by-basin basis. The number one request we get from county and other local planners is for more information related to groundwater. Where is it? How much is there? What is its relationship to surface water? What is the water quality? Oregon has often set the standard in water resource policy and implementation. Since 1909, Oregon's Water Code has created a rational system of water allocation and distribution throughout the state. Other examples of leadership include Oregon's Groundwater Act of the 1950s, the Beach Bill of the 1960s, the Land Use Planning System in the 1970s, recognition of in-stream uses as beneficial uses in the 1980s, and the Oregon Plan for Salmon and Watershed in the 1990s. During the past decade, Oregon has adopted a number of strategies and policies in order to better position itself in the areas of fish and wildlife conservation, ecosystem services, energy development, economic development, and water. Oregon has a solid legal and scientific history in place, providing a strong foundation for economic development, public health, and environmental protections in the water arena. The Integrated Water Resources Strategy recognizes the importance of Oregon's legal, scientific, and institutional foundation and commits to continuing and strengthening it. What the state hasn't done particularly well in recent years is made a sustained commitment in the areas of data, field personnel, and agency coordination in order to implement these policies and programs. Also recently, there has been no major state investment in water supply development compared to other western states. In 2009, the Oregon Legislature passed HB 3369, directing the Water Resources Department to lead efforts to understand and meet Oregon's water needs. These water needs refer to both in-stream and out-of-stream needs. The department was directed to take an integrated approach, looking at water quantity, water quality, and ecosystem needs, today and in the future. To do this, the bill directed the Water Resources Department to partner with the Department of Environmental Quality, Department of Fish and Wildlife, Department of Agriculture, and other agencies, tribes, stakeholders, and the public in the development of this strategy. HB 3369 specifically asked this team to account for coming pressures and called out climate change, land use change, and population growth and shifts as examples of those coming pressures. The project team used a 5-stage process in order to develop Oregon's first integrated water resources strategy. In 2009, the project team set the stage by developing a work plan, issue papers, a map gallery, 3 advisory groups, and a listserv in order to better communicate. In Phase 2, which occurred in 2010, the project team identified water resources needs. The project team did this using a heavy focus on public outreach, with 11 open houses, dozens of stakeholder workshops, a survey, several public comment periods, and our advisory groups. The project team developed a framework that laid out goals, objectives, guiding principles, and critical issues for the strategy. In 2011, the project team developed a discussion draft that included draft recommended actions and gave stakeholders and the public an opportunity to provide feedback. And in Phase 4, during 2012, the project team produced Oregon's first integrated water resources strategy. The Water Resources Commission formally adopted the strategy in August 2012. Phase 5 is a 5-year period, running from 2012 to 2017, that includes the implementation of recommended actions found in the Integrated Water Resources Strategy. The Water Resources Commission is directed to review and update the strategy every 5 years thereafter. Oregon's Integrated Water Resources Strategy provides a blueprint to help the state better understand and meet its water quantity, water quality, and ecosystem needs. The strategy has 4 primary objectives: The first objective is to understand Oregon's water resources today. Oregon needs to fill the knowledge gap, gathering, processing, and sharing information on the state's water resources so the state can better characterize our supplies and systems both for economic development and a healthy environment. The 2013-15 work plan places heavy emphasis on the collection, processing, and sharing of information that helps us make water-related decisions. 5 of the state's natural resource agencies have developed budget requests focused on determining the quality and quantity of surface water and groundwater. The second objective is to understand Oregon's in-stream and out-of-stream needs. Oregon needs a better grasp of current and future water needs, both in-stream and out-of-stream. Without a better characterization of current water use and future water quality, water quantity, and ecosystem needs, the state cannot adequately plan to meet these needs in the future. The 2013-15 work plan in this area focuses on improving water use measurement and reporting by proposing funds to provide cost share, by reauthorizing staff who can help water users with their continued reporting requirements, by supporting water masters in the field, and by authorizing the update of contact information. This part of the work plan also includes an interagency budget request to determine with more specificity the need for in-stream flows. There are many ongoing efforts to understand and respond to emerging pressures that will affect both water demand and water supply. These pressures include energy development, climate change, economic development, population growth and shifts, land use change, infrastructure needs, and education and outreach. While continuing their programmatic work in these areas, state agencies have no new policy or budgetary requests in this area for 2013-15. The fourth objective is to meet Oregon's in-stream and out-of-stream needs. Oregon needs to integrate and coordinate both the long-term planning and day-to-day management of Oregon water resources among local, state, federal, and tribal governments, as well as other state partners. Key actions here include state-level and place-based planning, water resources management and development, protection of public health and environmental health, and stable funding. The 2013 work plan designed to help meet Oregon's water needs is very full. 4 of the state agencies have developed several budget and policy requests that will help the state implement the Integrated Water Resources Strategy, and that will help local communities engage in water resource planning and implementation as well. Of particular note is a budget and policy proposal that will position the state to play a more active role in water supply development projects, benefiting both in-stream and out-of-stream interests. What's next? The 77th Oregon legislative session begins in January of 2013. Bills will be introduced at that time. In February of 2013, legislative hearings begin. By July, the legislature will have wrapped up its 2013 session. The next strategy is due to the legislature in 2017. This concludes the presentation. Please direct any follow-up questions or comments to the project team. Our email address is waterstrategy@wrd.state.or.us. Thank you.